Okay. Hello everyone, very good morning. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S Exam Prep. Today in the monsoon series, we are going to discuss one simple concept of predicate logic, that is what are the different equivalences and implications which holds true in the predicate logic. So let's start. So this is a brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience and following are the achievements and areas of expertise. Now, there's an announcement for all of you that BYJU'S Exam Prep is going to conduct a national scholarship test for GATE exam. This test will be conducted on 6th of August at 9 a.m. Do participate in this test and you may avail up to 90% off on all our programs. Okay, so what is the topic? Equivalences and implications in predicate logic, means logical equivalence and logical implications already. Now, so please try to recall from the last class that we have already proved some of the implications and equivalences using the relationship diagram. What, sir? For all x, for all y, Px comma y is equivalent to for all y, for all x, Px comma y. We have already proved all this, right? What else? There exists x, there exists y. Px comma y is equivalent to there exists y, there exists x, Px comma y. What else? So these two are the equivalences. Now the remaining one, there exists x for all y, Px comma y logically implies for all y there exists x, Px comma y, and there exists y for all x, Px comma y logically implies for all x there exists y, Px comma y. I hope this thing is clear to everybody from the last session in which we discussed the concept of relationship diagram. So this four things, two equivalences and two implications, can be easily derived from relationship diagram. And there are other implications also which can be seen using the relationship diagram, but we prove everything in the relation diagram based on these four statements, right? Now, let's look for something else. What's up? So, these are the implications or equivalences for the simple predicates but with multiple quantifiers. There is no conjunction, no disjunction, nothing, right? But now we are trying to check. Now the quantifier will be single, that means the predicate will be with the single subject, but let's see what I am trying to say. So if I say for all x, Px or with Qx, and if I distribute it as for all x, Px or for all x, Qx. So that's one thing. Now what we need to do is that, okay, these are the two things which we just need to check one simple thing, that what relationship will hold between these two. One, whether LHS will logically imply RHS or RHS will logically imply LHS, and if both of them are true, then it will be equivalent. So whether it is equivalent or only LHS implies RHS or only RHS implies LHS or none of them is true, that's what we are going to check. So these are the three things which you need to check. One, whether it is true. Second, whether it is true. If both 1 and 2 are true, then third will also be true. So that's first thing, right? Now, also second one which we need to check is, so this is with respect to for all, that whether how the disjunction will work with the for all quantifier. Now let's check that how existential quantifier will work with the disjunction. So second one, there exists X this is quite simple, but see, this is very important because you may remember these 4 rules, but if you do not understand that how actually the implication or equivalence is derived, then in the problem, I mean, the options may be corresponding to this one of 4 rules, but the options may be different, and most of the time 1 or 2 options will be from these 2 rules and other 2 options will be different. So how do you analyze whether those other options are valid or invalid? That's what we are trying to understand. So there exists X Px disjunction with Qx. There exists X Px, then you have distributed there exists Qx. So this is with respect to disjunction. Now let's try to understand with respect to conjunction. That if I say for all X Px and Qx, so can we distribute it for all X Px conjunction with for all X Qx, similarly for conjunction with existential quantifier. So we'll see them one by one. That what relationship will hold between LHS and RHS. So let's start with the first one. Let's start with the first one so that the logic will be clear, right? What does it say? Now, what we need to check is if LHS logically implies RHS, then it means whenever LHS is true, RHS should also be true. Whenever LHS is true, RHS should also be true. Now, for all X, that is for all the X in the universe, so we will have to consider a universe. Let's assume the universe consists of 3 elements, 1, 2, 3, right? Now, when this overall predicate formula will return true, when this overall predicate formula will return true, it will return true if for all the X, the union of P and Q is true. So the idea is, if these are the 3 elements, 1, 2, 3, then basically you will check for the union P1 union with Q1 or with Q1, P2 or with Q2, and P3 or with Q3. Now the simple logic is, if all of them are true, then only LHS will be true. But please try to understand, it is asking for the OR operation to be true. So if any one of this Q, P or Q is true, then disjunction will return true. So please try to understand this, that it is not necessary for this particular thing to be true. For LHS to be true, it is not necessary that P is true for all values of universe or Q is true for all values of universe, but the idea is either P or Q must be true for all the values of universe. So the conjunction of P and Q must be true for all values of universe. So let's try to understand that here this P1 is true, this P2 is false, and this P3 is true. Here, let's try to understand this Q1 is false, this Q2 is true, and this Q3 is false. Clear? So, please look into this, or you can keep this 2 as true, no problem with that also. So, P1 is true and Q1 is false. So, ultimate result will be true. P2 is false but Q2 is true. Therefore, P2 or with Q2 is true. Similarly, P3 is true. Therefore, P3 or with Q3 will be true. So, do you see that for all the values of X, LHS is true. Now, tell me whether in this particular scenario, RHS will be true or not. RHS will be true or not. So, the logical thinking is, sir, here we are checking that this OR operation of P and Q must be true for all the X. But here we are saying either P should be true for all X or Q should be true for all X. So, for this conjunction, for this disjunction to return true, either this for all X PX should be true or this for all X QX should be true. Means either P should be true for all X or Q should be true for all X. Right? So, but please check in this particular scenario, P1 and P3 are true, but P2 is false. Therefore, this thing is not valid. It will be false. Similarly, with respect to Q, Q2 and Q3 are true, but Q1 is false. So, Q is not true for all the values of X. Therefore, for all X, QX will also return false, and this disjunction will eventually return false. So, the idea is when LHS is true, RHS may be false. When LHS is true, RHS may be. I am not saying that it will always be false. I am not saying that it will always be false, but when LHS is true, RHS may be false. Therefore, one thing is guaranteed that LHS does not logically implies RHS. Clear? Clear? Now, if any one of these two implication, 1 or 2 is false, then ultimately it cannot be equivalent. Why? Because for equivalence to hold true, P should logically imply Q and Q should logically imply P. What the idea? So, equivalence also does not hold true. But let's check whether RHS logically implies LHS or not. So, please try to understand. For RHS to be true, either P will be true for all X. Now, just assume if P is true for all X, then ultimately P1, P2, P3 all will be true. So, whatever the value of Q, Q1, Q2, Q3 are, ultimately the disjunction of P1 union Q1, P2 union Q2 and P3 union Q3 will be true for all the values of 1, 2 and 3 because P1, P2 and P3 are true. Similarly, if Q is true for all X, then also this LHS will be true. So, you can eventually understand that whenever RHS is true, it is guaranteed that LHS will also be true. It is guaranteed that LHS will also be true, right? So, what do we know? The first is not valid, therefore, third is automatically not valid, but the second one is valid. Second one is valid. So, what relationship hold between LHS and RHS? So, the relationship is that for all X PX, disjunction for all X QX, this is your RHS actually. This logically implies for all X PX or QX. Got the idea? But other two will not hold true. But other two will not hold true. Or clear? That's it. That's the first one. Let's check for existential quantifier. Now, again, three things. Just check whether LHS logically implies RHS or RHS logically implies LHS or they are equivalent. Clear? So, again, three things needs to be checked. Let's see, this is first one, second one, third one. So, let's check for the first one. Okay, guys, it's easy. It's easy. Please try to understand this, that their exists will return true if for at least one value of X, their exists will return true if for at least one value of x, this disjunction of px and qx is true, right? So what's the idea? Sir, for at least one value of x, this px or qx can be true if either p or q is true for any value in the universe. Let's assume, please try to understand, let's assume that only one value is true and all other are false. Whatever, whichever you, let's choose p2 is true. Let's choose p2 is true and all other values p1, p3, q1, q2, q3, all of them are false. Then what will be the value of LHS? What will be the value of LHS if either p or q is true for any of the value in the universe? So if p or q is true for any of the value in universe, so what will happen? Sir, when we'll check with respect to p2, what will happen? p2 or with q2 will be what? Sir, p2 is true or with q2 is false, and this overall thing is true. So for at least one value of x, that is for x equals to 2, this disjunction is true, therefore their exists will return true. Therefore their exists will return true. Their exists will return false only if, please try to understand, their exists x in this particular case will return false only if both p and q are false for all the values in the universe. Both p and q are false for all the values in the universe. Got the idea? So LHS will be true if any, LHS will be true if any one if any one of these two, p or q, is true for at least one value in the universe. Now let's look for the RHS, that if any one value in the universe is true for either p or q, then what will happen with the RHS? So let's assume if at least one value if for at least one value in the universe p is true, then there exists x, px will return true no matter what is the value of false. It will become don't care. It will become don't care. Now the result will become true. If q is true, so let's assume all the values of q are false, but if at least one value of p is true for at least one element in the universe, then there exists x, px will return true, right? So here also either p will be true for at least one x or q will be true for at least one x. Then I mean p and q may be true for more than one values of x, but LHS will be true if p or q is true for at least one value of x. I am saying if p or q is true for at least one value of x, then what will happen with the RHS? So if p is true for at least one value of x, then also RHS will be true. If q is true for at least one value of x, then there exists x, qx will become true. In that case, whatever the value of, if there exists x, px is, this will also be true. Clear? Now this RHS can be false only in one condition, when there exists x, px is false as well as there exists x, qx is false, and it can happen only in one situation. It can happen only in one situation when p is false for all the x as well as q is false for all the x, and in that scenario LHS will also be false. LHS will also be false. So you know that whenever LHS is true, RHS is guaranteed to be true. Whenever LHS is true, RHS is guaranteed to be true. Therefore this LHS logically implies RHS. Sir, by this time you have also understood that if RHS is true, then for RHS to be true, the only case when RHS can be false is that when both there exists x, px as well as there exists x, qx returns false. That means p is false for all the values of x as well as q is false for all the values of x, then only this RHS will become false. But we are worried about the true condition when we are looking for the implication. So this RHS will be true if either p is true for at least one case or q is true for at least one case. So if p is true for at least one case or q is true for at least one case, then RHS is true, and in that particular case LHS will also be true, because this is the same definition, that LHS will be true if p is true for at least one case or q is true for at least one case, right? So if LHS is true, then it is guaranteed that RHS will be true. And if RHS is true, then it is guaranteed that LHS will be true. Therefore, this third implication, that is RHS implies LHS is true. Now, LHS implies RHS is true, as well as RHS implies LHS is true. Therefore, this equivalence is also true. Therefore, this equivalence is also true. So, if I just need to define that what is the relationship between LHS and RHS, then this equivalence alone will suffice, because this equivalence will automatically hold two conditions, that LHS logically implies RHS and RHS logically implies LHS. So just note it down, that what is the relationship between LHS and RHS. Right, so this two will be equivalent. So this is the observation. But why do we say that these two are equivalent? I have explained. Clear? And the similar logic you need to apply for the options given in the question. Similar logic you need to apply for the options given in the question. Now, third one. So these two are with respect to disjunction. Now let's try to understand with respect to conjunction. So, sir, wow. Sir, when exactly this LHS will be true? Please think. When exactly LHS will be true? Think. When exactly LHS will be true? Sir, it is quite simple. How? Sir, this is for all and the operation is conjunction. Means for all x, this conjunction should be true, and conjunction is true when both LHS as well as RHS of the conjunction are true. So this should be true as well as this should be true, then only this will return true. It means LHS can be true. It means LHS can be true only when both P as well as Q are true for all x. Yes or no? LHS will be true. Don't need to write. LHS will be true only if both P as well as Q are true for all x. All x, right? So if you say that universe is 1, 2, 3, then for LHS to be true, P should be true for all the values of x as well as Q should be true for all the values of x. Now tell me, in the same scenario, if we are saying LHS is true, means both P and Q are true for all x. So if both P and Q are true for all x, then P is true for all x will be true, as well as Q is true for all x will also be true. That is, whenever LHS is true, RHS is guaranteed to be true. Whenever LHS is true, RHS is guaranteed to be true. Therefore, the first implication holds true. Similarly, when we talk about RHS, then RHS will be true when this conjunction is true. So, for this conjunction to be true, this LHS must be true as well as RHS must be true. What is LHS? That for all xp should be true and for all xq should be true. So, for all xp should be true and for all xq should be true. This it means p and q both are true for all x. And if it is the case, then LHS is guaranteed to be true. Clear? If this is the case, then LHS is also guaranteed to be true. So yes, RHS logically implies LHS. If you have any doubt, then please let me know. That we are saying RHS will be true when this conjunction is true. RHS will be true when this conjunction is true. Conjunction is true when both LHS and RHS of conjunction are true. So LHS of the conjunction is that P should be true for all x and RHS is that Q should be true for all x. That is, both P and Q should be true for all x. And if both P and Q are true for all x, then the conjunction of P and Q will also be true for all x. Then conjunction of P and Q will also be true for all x. So yes, we know that because LHS logically implies RHS and RHS logically implies LHS, therefore equivalence will hold true. Clear? So what is this? For all x, Px and Qx will be equivalent to for all x, Px and for all x, Qx. That's what is the takeaway with respect to this third example. Clear? Now let's look for the conjunction with respect to existential quantifier. So again we need to check this three things. Whether first one will hold true or third one will hold true. If both first and third hold true, then second one will hold true, that is they will be equivalent. So let's check. Again. This is important. This is where people fail to understand the concept. Good morning, Swathi. Good morning. So, what do we say? Sir, this LHS can be true for what condition? So, LHS, if there exists at least one x such that the conjunction of P as well as Q is true for that x, then this there exists will return true. So, what's the idea here? It says P and Q both must be true for simultaneously. For at least one x. Yes or no? P and Q both must be true simultaneously for at least one x for LHS to be true. Getting the idea? So, if you have the universe as 1, 2, 3, then either P1 and with Q2 should be true, or P2 and Q2 should be true, or P3 and Q3 should be true. Then only this there exists can return true, that for at least one x the conjunction of P and Q must be true. Right? Now let's look at the idea. Sir, if for at least one x the conjunction of Px and Qx is true, then it means P is true for at least one x as well as Q is true for at least one x. Yes or no? If conjunction of P and Q is true for at least one x, then it is guaranteed that P is true for at least one x. So if P is true for at least one x, then there exists x, Px will return true. And because conjunction of P and Q is true for at least one x, therefore Q is also true for at least one x, therefore there exists x, Qx will also return true. That is, whenever LHS is true, RHS is guaranteed to be true, because the LHS as well as RHS with respect to this conjunction in the right hand side part of the implication will hold true. Clear? So whenever LHS is true, RHS is guaranteed to be true. Therefore, the first implication, that is LHS implies RHS, holds true. Now what about RHS implies LHS? Please try to understand. Okay, please try to understand. This is with respect to. Now the idea is, for RHS to be true, the only constraint is for RHS to be true, the only constraint is what? That P should be true for at least one x P should be true for at least one x, and Q should also be true for at least 1x. Now the thing which you need to understand is that P should be true for at least 1x and Q should be true for at least 1x, but not necessarily for same x. Yes or no? Not necessarily for same x. Yes, so let's assume that let's assume a situation that if universe consists of three elements, universe consists of three elements 1, 2, 3, and let's say this is P, this is Q. If I say that for the different values of universe, that is 1, 2, 3, if I say P is true for 1 but false for 2 and 3, P is true for 1 but false for 2 and 3, at the same time Q is true for 3 but false for remaining 2. So please check whether RHS is true or not. Yes sir, P is true for at least 1x, therefore this there exists xpx will be true. Q is true for at least 1x, therefore there exists xqx will also be true, therefore this conjunction will be true. But what will happen with the LHS? What will happen with the LHS? P1 conjunction with Q1 is false, P2 conjunction with Q2 is false, P3 conjunction with Q3 is false. So this LHS is not true for any x in this given scenario. This LHS is not true for any x in the given scenario, therefore their exists will return false. So yes, there is a situation in which the RHS can be true and LHS can be false. RHS can be true and LHS can be false. So yes, this RHS will not logically imply LHS, and if RHS does not logically implies LHS, then obviously they cannot be equivalent. So what is the takeaway related to equivalence, related to equivalences? So what equivalences? So for all will be equivalent with respect to and, that is for all x px and qx will be equivalent to for all x px and for all x qx, and their exists will be equivalent with respect to or, that is there exist x px or qx will be equivalent to there exist x px or there exists x qx. Clear? What are the implications? What are the implications? Sir, implication. So implication is generally confusing because people can simply remember that okay, for all is equivalent with respect to and there exists is equivalent to with respect to or, but with respect to implication these are in two opposite directions. Good morning Anil. They are in two opposite directions. What that for all x px or for all x qx implies, so here this if for all x px and for all x qx are distributed, then they can eventually be merged. That is, will imply for all x px or qx, right? But with respect to and, it is opposite. With respect to and, what will happen? There exists x px and qx. There exists x px and qx will logically imply there exists x px and there exists x qx. What the idea? So this is your takeaway from this particular thing, that yes, and generally people try to remember this equivalences and implications, that okay, this is true, this is true, this is false, this is false. But what my concern is that you may remember this four formulas, but the question, in the question, the options may be of the similar type, and if you don't know the concept that how do we really prove that these two are equivalent, or how do we really prove that in these two cases LHS is logically implying RHS, then you may not be able to give the answer for the questions in which the options are not directly from this four rules, Therefore, please try to understand that when you want to check the equivalence or logical implication, you just need to see that what is LHS, what is RHS. Whenever LHS is true, what will happen with the RHS? When RHS is true, what will happen with the LHS? If any one of them, that is when LHS is true, if RHS can be false, or if RHS is true, then LHS can be false, then they cannot be equivalent. There may also be the situation where neither LHS implies or logically implies RHS, nor RHS logically implies LHS. So please make sure that you understand. And so please don't think that these are the only four equivalences or implications. Don't think that these are the only four valid equivalences or implications, but these are the four general equivalences and implications which can be used directly as a rule to solve the question. This can be used directly as a rule or axioms to solve the questions. But otherwise, if some other statement is given, then you will have to prove it. You will have to observe the statement for checking the validity of that particular predicate formula. Clear? So these are the thing that yesterday we have seen, this four predicate equivalences and implications. These two are equivalent, these two are implications, and today we know about two more equivalences and two more implications. Done? Now we know everything, how the negation will work, how do we read the statement, right? So basically, if somebody says that P is a politician and Q says is a sportsman, then I already told you there exists X, Px and Qx. Then at least one X should be of the type such that X is a politician and X is a sportsman. So this will be true if only if at least one person is politician as well as a sportsman. So this is the way of reading the predicate logic, because in most of the question the statements will be given and you will have to frame the predicate formulas for them. But don't worry, tomorrow at the same time we will solve the PYQs related to predicate logic, and I'll tell you that what are the different types of questions which can be framed and how do we solve them based on the knowledge which we have achieved in 2-3 lectures, right? So please try to understand discrete predicate logic is not difficult. The only problem is that people are not attentive while learning the concept related to predicate logic. Clear? So this is a very simple concept and very limited things which needs to be learned, but the applicability is difficult. So in tomorrow's session, we will try to understand that how we can apply the concept which we have learned in this 2 or 3 sessions on all the questions which has been asked in the GATE, and using this concepts only we will be able to solve each and every question of PYQ. So yes, it's and obviously the another knowledge which is required is the knowledge of propositional logic, which we have already discussed. So predicate logic is just an extension of the propositional logic. So you cannot solve the question of predicate logic until you know the concept of propositional logic, because all the rules of inference which we discussed in the propositional logic will also hold it true in the predicate logic. There are 4 more rules of inference, but if we are not solving the questions related to them, then you will just think that what is this, right? Therefore, I'll explain those 4 rules of inference along with the question, and you will say, oh, these are not the rules. We already know that this happens, but the names are given to those rules. One is universal generalization, another is universal specification, one is existential generalization, another is existential specification. But name of the rules are given, but those are just the general understanding related to the concept. Anyway, we'll solve the questions in the tomorrow session. Good morning, Shangu. And yesterday I could not complete this session on YouTube related to LR1 items, construction of DFA of LR1 items. So tonight we'll complete this session of this particular thing, and that will be all. Clear? So just a small session related to equivalences and applications, so that you understand that how equivalences or implications are defined with respect to predicate logic. So I did not give you the rules directly, but I have explained that how to prove them, so that if any other implication or equivalence holds true, then you will be able to identify it. Thank you very much, guys. Okay. Does any one of you have any doubt? Then please let me know. Otherwise, we'll wrap up the session. If anybody wants to ask anything related to predicate logic, then let me know. Otherwise, we'll end the session, because we have completed all the concepts of predicate logic. Whatever left, we'll see in terms of PYQ. Okay. So that will be all. Thank you very much. Good day.